Calculating ratios.
Calculating ratios. Yeah, that's where we're at in the book. Now, we, of course, if you look at the book and you look at what we're doing as far as our calculations are concerned, we've deviated a little bit, but you're learning ratios, and you're learning ratios as far as they pertain to the industry itself. So we're going to continue with that. Professor V, as you noticed this morning, those people that were here already went ahead and he's going to go ahead and post Ohm's Law. And I'll show you that in just a moment. We're going to start introducing Ohm's Law into the equation and start using those numbers and formulas to be able to do computations on transformers and conductor and all kinds of stuff that's out there in the world. So just as a refresher, let's go ahead and pull a couple of these up right here and make sure that we're all back on the same page again. So I'm going to draw a transformer in. Everybody does see my screen, correct?
Yeah.
Okay, thank you very much. All right, and I know my transformer doesn't look like real life. So we'll start out coming into the transformer. I have 7,200 volts. You ground this bushing right here. And coming out of my transformer total, remember we have to use the total output voltage, is 240 volts. What's the ratio between the primary top side and the secondary bottom side? How do we do the math? We take
30.
Yeah,
1 to 30.
You're right. We take 7,200 divided by 240.
It's 30 over 1.
Yeah, that'll give us 30 right there. And the easy way to remember where do I need to put the 30 is 30 times 240 equals 7,200. Bang, bang, bang. All right. No matter what numbers. Now, the chart that Professor Bermerlin gave to you yesterday are the typical primary and secondary voltages. Whatever numbers I plug in for primary and secondary, the math is still the same. All right. So let's go ahead and clear all that. We divide and then we figure our ratio, 1 to 30. All right. File, new, save. All right. One more. Welcome back, Professor V.
I'm back.
19,900 volts. And we're going to go 480 volts on the secondary side. Our math, 19,900 divided by 480. Somebody do that math for me. Anybody?
41.45.
41.45. I know that I'm computing for the secondary side, so I'm going to put 41.45. If I need to check my work, I can go 41.45 times 480 should equal 19,900 or very close to it. We're rounding sometimes. Don't try to round too much. Always keep it at least to the 10th and multiply those numbers and go in those directions. Okay, so I think we're square as far as figuring ratio. 1 to 41.45 when we have two voltages. One is our primary voltage and one is our secondary voltage coming out of the transformer. All right. So now that we have that information, and we'll use the first one that we had, now we're going to include amps. And we'll go back to our original. We've got 7,200 volts in. We've got 240 volts coming out. And I know this is probably getting monotonous in the numbers. I know it right off the top of my head. 1 to 30. Either side now, the primary or the secondary side, if I now give an amp value, I'm able to calculate for the other side, top or bottom. So if I give an amp value up top, 10 amps, and I'm going down in my calculation, and I'm looking for amps here, I need to multiply. 10 times 30 equals what?
300.
300. There you go. So that's my answer. How many amps do I have on the secondary side? 300 amps if I have 10 amps on the primary side. Let me see if I can just go backwards in this control. Oh, yeah. Well, there it goes. If I have an amp value on the secondary side, and I'm looking for, let me erase this. And I'm looking for an amp value on the primary side. Now all I need to do is divide. So I've got an amp value on the secondary side, 210 amps. The ratio still stays the same. Now I'm going to divide by 30, and it's going to give me the amp value for up there, 210.
7.
Divided by 30, exactly. It's going to give me 7 amps. 7A, and that was the one I was asking for.
Professor.
I think somebody's asking a question there.
Yes, sir. Where's the 30 coming from? I'm lost on that one.
That's fine. That's fine. That's why we do this multiple times. File, new. That's that. Okay, here comes my transformer. One, two, three. Now my input voltage is 7,200 on the transformer, and this is just the way the transformer comes from the factory. I'm not, making this up. This is a factory provided transformer. The output voltage is 240. At this point in time, in order for me to figure amps either here or here, I need to know what the ratio of the transformer is. Now there's a voltage ratio and there's a windings ratio in the transformer. Right now we're working with volts. To get my 1 to 30, and you need to get it down to 1, I'm going to take 7,200. That's that number right there. And divide it by 240. That's that number right there. What does that give me? 30. That's where the 30 number is coming from. Where to position the 1 to 30 at is 1 goes on top. You want to have 1 on top all the time. And the number that you calculated goes on the bottom, secondary side. To check my work, I'm going to take 30 times 240 should equal 7,200, and it does. So that's where my 1 to 30 is coming from. Does that help?
Yes, sir. Thank you.
No problem whatsoever. Good question. That's typical and normal for that question to come about. Okay. So, any questions as far as doing the computation? 1, to find the ratio. 2, to find the amperage values wherever the question is asking. So a typical question is going to come out on a test, and it's going to look like primary voltage equals 7,200. Secondary voltage equals 240. What is the ratio? And Professor V and I, as far as grading are concerned, we love multiple choice and true false. I hope you guys do too, because pretty much it automatically grades. What is the ratio? And typically, I mean, the questions are going to get more difficult, but when we go down the list of questions, we're not going to bombard you with multiple formulas that you have to perform in one question. We're going to ask this one, and we're going to go all right, what's the answer?
One to 30, isn't it?
1 to 30, yeah. I've got, grab your piece of paper out to the side. You really don't need to be a good transformer drawer.
Yeah.
7,200 on top, put 240 on the bottom. I'm not going to draw the transformer in. Okay, divide 7,200 by 240. It's actually sitting here as an equation. What does it give you in response? 30. Ratio, 1 to 30. Done. There's your two numbers that you need to use. I can guarantee you we're going to plug in different numbers. But as far as the formula is concerned, this is it. Take the primary number, the higher value number, primary voltage, divide it by the secondary voltage, and get down to this number. Now, we talked about this yesterday morning too. Sometimes you might run into this. And I'm going to short term it. Primary equals 19,900. Secondary equals 240. What do I need to do? 19,900 divided by 240. Somebody run that math for me, please.
$82.91.
82.91. I think that came up yesterday.
Yeah.
So my answer is 82.91. My ratio is 1 to 82.91. That's just how you figure out. In the real world, we're not doing complex math. In the real world out here, this is actually a ratio. That is a fraction. But we're not worried about it for the work that we have to do as far as computing on a transformer. So if you want to get away from my transformer picture right here, I'm just going to use this one because we got it sitting already up. 1, sorry about that, let me undo that. 1 to 82.91. Now, when we give the quizzes and when we ask these questions right here, one is you're going to have to figure what the ratio is, and we're going to have to give you one of the amp values. All right, that's got to be in the question, and we will give that to you. All right, this side has 7 amps on top. What are the amps on the bottom? 7 and
7.
Nope. If 1 equals 7, what does 82.91 equal? We're going down in the calculation.
You got to
You
multiply
multiply.
7.
You gotta
by
multiply it. There you go.
82.91.
So we're looking at, go ahead and do it.
Five
580.41.
580.41. Answer. Perfect. All right. That's if you calculated the ratio. You did that right here through that math. We provided an amp value and asked you, what is it on the secondary side? Watch out. File, new, don't save. 1, and we're going to use the same numbers here. 1 to 82.91. All right, I'm going to give you a value here. What was the last answer?
580.41.
580.41?
Right.
All right. Okay. What are the primary amps? Question mark. I'm going this direction now. What kind of math do I need to use?
Divide those two, right?
There you go, divide. I bet you it's going to be 7.
It came out like 7.000.
There you go, 7.00. We usually go to the 10th. Okay, so we're fine. All we did was we took the 7. First time we took the 7, used the ratio that we'd already figured from the voltages, and we got this number right here, 580.41. I just plugged the same number back in. We just went in reverse and did divide and got the same number up top again, 7.00. The thing that you need to look out for in quizzes is whatnot is my voltages are going to change. My amperages are going to change as far as what I'm giving you to ask the question on. You need to just know the formulas. The formula for figuring out the ratio. And if I give you a value on top, bang, 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 and I'm calculating down, I multiply. If I give you a value on the bottom, and I'm asking for the primary voltage up top, primary amperage up top, you divide. What time are we holding there, Mr. V? It feels kind of late.
9:52.
9:52. Okay, I think this is a good stopping point right here.
Yep.
Let's say 10:05. Let's go ahead and take a break and come back and be back at 10:05.